Hello, this is the sixth in a series of videos addressing the installation of Cisco Modeling Labs version 1.2. After customizing the Cisco Modeling Labs server, we are now ready to deploy the client software providing the user services of Cisco Modeling Labs. In this module, we will examine the Cisco Modeling Labs client application. We will look at the process to download and install the software. We will then perform the necessary steps associated with integrating the CML client to the Cisco Modeling Labs server. Once we complete the integration of CML client to the server, we'll explore the CML client's interface. We'll then create and launch our first topology simulation. The CML client is the graphical tool used to create and control network simulations that run on the Cisco Modeling Labs server. It is an Eclipse-based GUI that is used to design, build, and visualize network topologies. It also launches these simulations into the Cisco Modeling Labs server. Using the AutoNetKit function, it enables rapid prototyping of topology designs. This added value feature employs various templates to perform automated configuration generation and resource and addressing assignments. It facilitates console access to the running virtual devices within a simulation. It is the user interface to manage and control the running simulation. And it also provides the means to archive topology designs for later reuse or sharing to enable collaboration with engineering peers. The CML client runs on workstations based on Microsoft Windows or Apple OS X. The workstation must be fitted with a minimum of 500 megabytes of DRAM and needs 200 megabytes of local disk space. For Windows workstations, the client software runs under Windows 7 or Windows 8, with 32-bit and 64-bit variants available. Apple OS X machines require version 10.8 or higher. For either platform, Java runtime environment is also needed with versions 6, 7, or 8 supported. The JRE should match the client with respect to 32-bit or 64-bit variants. To install the JRE and CML client packages, workstation administration privilege will be needed. Let's look at a demonstration of the process to download and install CML client on a Windows platform. In our previous module, we saw that Cisco Modeling Labs is preloaded with two user accounts: the UWM admin account that performs the root-level administrative role, and an archetype guest account that is associated with the guest project. We will first access the user workspace management pages to create a non-guest project and user account, and then disable the guest account. We will then download and install the CML client software, followed by its first launch. From the CML client interface, we will then modify some of the initial parameters. From your web browser, point to the URL of the CML server. On the initial splash page, click the User Workspace Management option. We'll log in with the UWM admin account. From the menu, choose Projects. Click the Add button. And let's add a new account called Test. We'll allow this to not expire. Notice that we have the account as enabled. And we could leave the quotas as they are, but we'll go ahead and drop these down to something more realistic for the time being. And then click Create. This will create the project space as well as the initial user account for this project, automatically taking us to the user page. The status message reports that the new account was created with a generated password and prompts us to change this as soon as possible. In addition to resetting the password, we can specify the role for this user as member or admin. Projects and users can be marked as enabled or unchecked for disabled, as well as set with an expiration date. When done, click Save. Going back to our projects, we see we now have a test project. Looking at users, we see we now have a test user. At this point, we can select the guest user and click the disable. We could also go to the project and disable the guest project. On the initial splash page, click the CML GUI clients. Select the appropriate installer for your workstation. In our case, we will select the 32-bit version for a Windows machine. Confirm the file save prompt and allow the transfer to complete. Check your designated or default download folder and launch the downloaded setup file. Follow through the steps of the install wizard as appropriate for your installation. On our initial start, we're presented with the license agreement. Click to remember my decision and then agree. At this point, we can enter the IP address of our CML server. And then use the account we just got through installing. We have to enter a new master password. And for ease, we're just going to type in Cisco for both questions. You would, of course, do something a little bit more significant. Our CML client shows the account with which we are logged in. And by clicking the button, we see that our web services are successfully interacting with the Cisco Modeling Lab server. Let's now take a minute to examine the CML client layout. At the top of the page is our menu banner, and directly underneath is our toolbar. At the center of the page is our design canvas, upon which we will draw our topologies. These network designs will be drawn using the topology palette to the left of the design canvas. Under the topology palette is our projects pane, containing topology folders archiving our project files. Under the design canvas is the properties pane. Within this section, we encode various parameters, options, and configuration elements that influence the resultant topology configurations. To the immediate right of the design canvas, or topology editor, is the node editor pane. This shows the interface details for the currently selected elements within the topology editor. Let's now use the CML client to build a rudimentary topology and then launch the simulation. We'll use the classic iOS type devices and then drop copies onto the topology editor canvas. Then select the Connect object. On the design canvas, draw links between the placed iOS vRouters. Note that as they are drawn, the node editor shows the associated nodes and the assigned interfaces. Let's add a couple servers and tie them into the routers. Clicking the canvas background, we can see the properties for the overall topology. For this quick exercise, we will not select a management network and will not use an LXC management job host. Selecting the AutoNetKit tab, we can see the overall attributes that will be employed building the configurations and applied globally. For example, we can set CDP or select IP version 4 as the address family. Scrolling down, we see the address pools that will be allocated, informing the configurations as well as some of the default settings that can be applied. Selecting a node, we can review or set device-specific settings. Our next step is to generate our configurations by clicking the Build Initial Configurations icon in the toolbar. As this is a new topology, the topology save opportunity is offered, after which the AutoNetKit builds our configuration. We are presented with the results, the left side showing the XML file that describes the topology, and the right side showing the generated startup configuration files for each of the nodes. We are then offered a visualization of the topology. The initial presentation is a physical layout and should closely match what was drawn on the canvas. However, there are a variety of selectable viewing perspectives and filters that may be applied to offer alternative vantage points. When the visualization display is complete, the topology may be launched. The CML client switches from design perspective to the simulation perspective. The CML client then interacts with the CML server to spin up the node simulations as virtual machines. As the virtual machines are spun up, they load the specified iOS images, followed by the AutoNetKit generated startup configurations. Once the virtual nodes have completed their loading, they initialize the defined interfaces, establish adjacencies, followed by the convergence of the optioned routing protocols. The color indication of the virtual node shows its status. When the node icon displays a green glow, the virtual machine is reporting as active. A similar indication is shown in the simulations view. Once the nodes are active, management sessions may be initiated. CML version 1.2 now has an active canvas that allows the sessions to be launched via the icons. A console session is started in the lower right corner. This can be expanded to full screen. When the simulation scenario is complete, click the Stop Simulation icon in the toolbar. Configurations that were added to the virtual nodes may be extracted and copied back to the client so that they may be saved in the project folders. When doing an extract, all console sessions must be terminated. An option is offered to do this if not already done. Once the config extraction is complete, the virtual machines will be shut down. The live canvas and simulations view will show the shutdowns process. And this completes our series covering the installation of Cisco Modeling Labs. In this last module, we downloaded and installed the CML client. We saw the first time use of the CML client. We created the server project and user account, and then we set the server access details to CML client. We navigated the CML client interface, and then created and launched a simple topology.